In this example, I need to solve the equation 3 divided by the quantity x plus 4 minus 2 divided by the quantity x minus 4 equals 3x divided by the quantity x squared minus 16. Well, what type of equation is this? Notice there are x's in the denominator, so it is a rational equation. And what are the first things we do in solving every rational equation? We want to find the least common denominator, and we want to find the restrictions on the domain. Now, to find the LCD, all our denominators need to be factored. Are they in this case? The first two are, but the third one is not. X squared minus 16 is the difference of two squares. And remember, when you factor the difference of two squares, you get two binomials. The first term in each parenthesis is the square root of x squared, which is x. The last term is the square root of 16, which is 4 and 4. And then you put opposite signs between them. So now I've factored the difference of two squares. I'm ready to find the least common denominator. And to do that, you go to your first denominator and you need an x plus 4. Go to the next denominator. Do I have an x minus 4 here? No, so you just multiply by x minus 4. Go to your third denominator. Do I already have an x minus 4? Yes, don't need another one. Do I already have an x plus 4? Yes, don't need another one. So this is my least common denominator. And to find the restrictions, we set the LCD, x plus 4 times x minus 4, equal to 0. And solve this equation. Two factors multiplied together equals 0. Set each of them equal to 0. So I have x plus 4 equals 0 and x minus 4 equals 0. The first one, subtract 4 from both sides. I get x equals negative 4. Second one, x minus 4 equals 0. Add 4 to both sides, you get x equals 4. So the restrictions are x cannot equal negative 4 and positive 4. So I'm going to have to check my answers against those restrictions. Next, I need to multiply every single term in the equation by the LCD. Since all these terms are fractions, I'm going to turn my LCD into a fraction by dividing it by 1. So here is the first term of 3 divided by x plus 4 multiplied by the LCD of x plus 4 times x minus 4, all divided by 1. Then I multiply the second term of 2 over x minus 4 by the LCD. And then finally, I have equals the third term on the right-hand side multiplied by the LCD. Now all I have to do is simplify this nasty-looking mess. In the first term, the x plus 4's reduce, and I get left with 1 times x minus 4 times 3 divided by 1 times 1 is 1. So it's just going to be 3 times x minus 4. I do not need to write the 1 in the denominator. Minus, in the second term, the x minus 4's reduce. I get 2 times x plus 4 times 1, which is just 2 times x plus 4, divided by 1 times 1, which is 1, which again I don't need to write in the denominator, equals, in the last term, the x plus 4's reduce, the x minus 4's reduce. I get 3x times 1, which is 3x, divided by 1 times 1, which is 1. So now I've gone from this nasty-looking mess to a simple linear equation. So to solve this equation, I need to get rid of the parentheses. So I'm going to use the distributive property. 3 times x is 3x, and then 3 times negative 4 is negative 12. Distributing in the -2, -2 times x is -2x. -2 times +4 is -8. And that equals 3x. On the left-hand side, I have like terms that I can combine. 3x minus 2x is 1x, or just plain old x. And then -12 added to a -8 is -20 equals 3x. It's going to be quicker to collect my x's on the right, so I'm going to subtract x from both sides. X minus x is 0, so I get -20 equals 3x minus x is 2x. Now all I have to do is divide both sides by 2. These two 2's reduce, and I get left with x equals -20 divided by 2 is -10. But I'm not quite done yet. I must check my answer against the restrictions. Is x equals -10 allowed? Yes, the only two values of x that were not allowed are -4 and +4. So I have shown that x equals -10 is not an extraneous solution, but I haven't shown it's a correct solution. To do that, I'd have to plug x equals -10 into the original equation and show that I got a true statement.